Hello and welcome back. If you have been watching the series of videos on writing a report using, and I'm using the Titanic data. So I'm up to this sort of second half of the results, and this is where I'm going to do some inferential statistics, but I'm not really focusing on the techniques in this video. I think I have previously recorded a video on doing logistic regression with this particular data set, so feel free to look that up. I will be doing it again, but my focus is really on how we present the results, less about the technique in this case. So I thought I would start off by talking about what would go into this section. And I hope I can do this concisely off the cuff because I don't have a script prepared. Well, I never have a script prepared, that's probably obvious, but anyway. So inferential statistics, this is where we have a specific testable null hypothesis, possibly more than one. I should clarify, we don't actually write this here. If you're going to have a testable, if you are going to write out your hypothesis, and in a lot of papers we don't, you won't see them written out anywhere, it's more likely that you would put them in the methods section or even underneath the aim at the end of the introduction. So check with your discipline about where they might go. Typically in health papers, the thing you're testing is, although you will have a research question written out, the actual hypotheses are implied by how you write the results. So that means that when you say something like, there was a significant difference in whatever it is after adjusting for other things, you're implying the analysis and the actual hypotheses. So you might not see these written out. Similarly, when you're controlling and adjusting for other variables, this is most likely going to be written in the methods, but you will still need to write it underneath where you have tables of results. You'll need to say what's been adjusted for what, but it may just be part of a bigger sentence. Often when people first start writing statistical conclusions, they really focus on the significance, which is your p-value. But that's not the end of the story, because p-value in a lot of, well, in all cases, there's going to be a strong effective sample size. That doesn't tell us how important the results are or how convincing the results are. You can get a very, very small p-value just from having a really, really large data set. So you also need to talk about effect size and the direction. I should put direction in there. Now, in this case, the word effect is being used to mean difference or whatever is going on. It doesn't necessarily mean cause and effect as we might have with an experiment. So when we say effect size statistically, we're talking about describing the difference between the two things that we're looking at, or the magnitude of the association if we're looking at associations. We're not talking about cause and effect, as in if you've got an RCT as opposed to a cohort, a cross-sectional study. So effect can be a tricky word to use correctly because it will get used differently in different contexts. So bringing this all back to what we're doing here, we're going to imply the analysis that we've done by how we present the results. And what I want to focus on is how we present really the main things that we're interested in, but particularly these, because they can sometimes be the most difficult to get your head around, I think, when you first start writing in this sort of format. One thing that I will say is that if it's possible to show your results using a graph, then I think that is a really, really good option. So I would always encourage using graphs. Some people, for some reason, feel that graphs are not scientific. I've never heard anything more ridiculous. Of course they are. It's part of science communication. So if you can find a graph which shows what you want to show, then I would recommend using it. Often the graphs that you learn in a basic stats course are not the ones that are going to end up in a final paper. They might be, but they might not be. So I've got a few examples. Let's have a look here. So I like this particular example because what they've done is they've used a nice, I guess it's a merge between a bar chart and a histogram. I don't know if this is truly continuous, but what they're doing is they're not showing the whole instrument that they've used, but they've shown some responses to a couple of questions I think to illustrate the pattern of responses, but also to illustrate the types of questions. So if you're looking at this paper quickly and you're not quite sure what a locus of control is, being able to look through a couple of the questions is actually really handy. So they didn't include these graphs for every single question on the instrument, but they included a couple of examples. So I think that's a really good thing that they've done. Where they have shown the relationship between the things that they're interested in, the locus of control and the healthy eating index, one, they've separated it out between men and women because the patterns were quite different. But two, they've included this shaded area for the 95% confidence interval. So it's not the only way to do it. And you'll notice that this is not smooth. I haven't read the details of what they did in the paper. But the point is that they are including a measure of uncertainty, and that's really key. Other ways that we might do this, so if you've got two continuous variables, you could do a scatter plot. If you're just interested in a simple relationship, you could graph that, and I think that's quite helpful. Sometimes we want to show the variety of responses. We want to show the uncertainty and all the things we don't know as much as the things we do. So there's nothing wrong with a graph that's got a whole lot of scatter on it. If you've done some kind of analysis here, but in your analysis you've actually controlled for other variables, it doesn't mean that you can't show a graph of the simple relationship too. As long as it's clear what's been included in each part, that's fine. I like this one here because they've actually included the uncertainty on the regression line as well as including all the raw data in the scatter. So I think this is quite a nice graph. Now, these are a little bit more unusual. It probably depends on your discipline. There's nothing wrong with including box plots. I think they're wonderful graphs. I don't think we see them enough in papers. I think this is a nice example of one. And the only addition that they've made is that they have actually marked the mean on the box plot with a dot. And then they've put the p-value in the figure legend. So you just have to remember that with a box plot, you only have the median marked. Usually by default, it probably depends a bit what software you're using. But they've put the mean on as well. Very unusual to see histograms in a paper. Hopefully you check them when you need to. But they do sometimes turn up, and this is basically standard SPSS output from, I think, anything before version, I want to say 23 from the looks of it, and they haven't made any modifications at all. At the bare minimum, I would probably change my colours, but the point is they've included some graphs, and I assume that they had a reason they probably wanted to demonstrate that their model did have normal residuals, because it might have been a critique when they first submitted it that was this an appropriate regression technique, because perhaps it was an unusual application with life satisfaction. I don't know, but they've included the graphs. Here we've got means and confidence intervals. I think you should give careful thought to anything you add onto a graph. This looks like an Excel graph, and they have joined the lines up. Now, I don't mind it in this particular context because this is a year-to-year survey as far as I know. So I think this is from the World Health Organization. So kind of linking these up, it doesn't offend me in this particular context. In this other example, we've also got means and confidence intervals, and you'll notice that they haven't joined them up. And I think that is a good choice because, as far as I know, this was a cross-sectional survey. So each of these is a separate group in one slice of time. It's not one age group sort of followed in a cohort study over the years. And whenever you join things up, there's an implied linkage. So I wouldn't want to imply any linkage here. You'll notice that they've also put some reference lines on. So when you are doing graphs to show your results, and these are pretty standard SPSS colors as well. So I'd say they haven't done much changing of the graphs here, but they have added in the necessary information. So have a think about what it is that you're trying to show with your results and find an appropriate graph. This was from the paper that also had the histograms, and you'll notice that their actual results are too complicated to go into a graph. So they've got a table, and obviously tables are very useful. If you can also have a graph to help explain some of the key points in your results, I think that's a really good idea. This is just an example of bar charts done really well. So this particular paper had a ton of outcomes. This is just a portion of their their outcomes, and they've color-coded it and they've smushed them all together. And so you get this idea of the strongly agree to the strongly disagree over these different medical conditions as to whether or not they're a disease. And they've managed to pack a huge amount of information into a small amount of space just through really clever use of labeling. They've paid attention to how they've labeled each disease. They've labeled each of their groups they're interested in. They've color-coded strongly agree to strongly disagree. So they've put a lot of thought into this and presented really effectively a lot of information quite compactly. So when we get to logistic regression, which is what we're doing for the Titanic data, because we have a binary outcome of survived or died, we've got a few choices as to how we can present the results. Commonly, you'll see odds ratios presented in tables, and you might see it in this format where we have the simple model. So this is called an income-only model in this particular paper, but this might also be called the unadjusted odds ratios, except they have done a little bit of stuff because they've got a slightly more complicated design with the adjusted odds ratios or fully adjusted models. So that's a really common way to present it. Here they've got different models or sets of predictors they're comparing, and they've done them, they've sort of stacked them vertically rather than having different columns. So that's another way, but they're also presenting odds ratios and p-values. Here they don't have the p-values, but they've got the confidence intervals, and they've got a little asterisk if they're significant. So this is a common way to present odds ratios. And then we also have this way, which is a graph, and it's a little bit tricky to produce in SPSS. So what I wanted to talk about was how we go about deciding how we're going to present our results and thinking through that process about what it is that we want to show. So you'll notice that they have a reference line at 1 because the odds ratios, the point of no difference is 1. If it's below that point, you get a reduced odds. If it's greater than that, you have increased odds. But it's not a linear scale. So we have to be careful about how we graph it because it's quite tricky. So this is a really, I think it's a really good plot for showing results for logistic regression. However, it's not a default option in SPSS. And you will find for a lot of these things, you don't necessarily get the output exactly the way that you want it. Like there would have been extra work that went into this. So going through that thought process and working out what is it that I want to show and then finding out how to do it, whether or not SPSS can do it, I think is a really valuable process. So if we have a look at our SPSS data and we want to run a logistic regression, we will just do one simple model. And I'm going to look at, is there a difference in passenger class after adjusting for gender? Now, I'm not going to include age. It's a tricky one. There's a lot of missing data for age, but also I'm not quite sure on the best age grouping. So maybe this might be something I could come back to if I had a bit more expert opinion on how to do this. I'm also not going to include fair because I think obviously that's going to be tied up with class, and I don't want to obviously use the same information twice. So I'm just going to use class and gender, but let's have a look at getting those results out. I was trying to think which way around I would do it. I think let's start with the graph and then we'll go to the actual logistic regression results. If I just wanted to get a graph of this out, because it's quite simple, I've only got 3 variables, I can show all of this on a single bar chart. And I think that actually is a good option for a lot of this type of data you can just show on bar charts, even if that feels like it's too simple for a scientific paper. Bar charts are quite handy. Now, in any way that you can use a stacked bar chart, you can also use a clustered one. I tend to have a preference for stacked ones, but it can depend on how many categories you're comparing. In this case, I know that this will work fairly well. So if I bring the stacked bar chart in, what I'm interested in comparing is the survival. So let me put that as the stack color. I'm thinking about this as I do it because I haven't done this for a while. And I want to compare this between passenger class So, but that doesn't have gender on it. So if we just do that first. So there's two problems with this graph. One is we don't have gender on it, which is something that I wanted. And the other is we've got a different sample size, or, well, total number. It's not quite a census, but nearly. We've got a different number in each of these classes, and that makes it very difficult to compare proportions. So we need it as a percentage, but we also need to get gender onto it as well. You can't always get everything that you want in SPSS, but there are ways to manipulate it above and beyond the options here. So trying to remember which way to do it. So groups, point ID. This is where we can add another variable. If you aren't sure which one you want, then try it both ways and see which one seems to show your results better. So if I go for a rows panel variable first, we have a look at it, and this is where I'm going to put gender on. I'm not sure I like this. We could have a look at this. I'm not finding this easy to read. So if I go back, I could try it a different way. So I'll take out the rows and I'll put it on as columns instead and try it again. Now that looks easier already. I still need it as a percentage, so I'll change that. And what I'm trying to illustrate by going through this process is that you don't necessarily have to know in your head exactly what you want before you start. Sometimes it's a process of trial and error as to what is the best way to show the results. Now I've put the percentages out of each x-axis category. So this is looking better. It's possible that it might be better if I swapped the sex with the passenger class. I'm not sure. You could try that, or it might be preferable to have these the opposite way around. And I've got sex coded different ways, so I could try it with a different coding. I don't know why that suddenly got more than 2 categories. See, I feel like that looks better than this because we can kind of follow what the results are as to survival. So we have the highest survival for women in first class, which I think everybody knew. We could do one last graph to check if it's better to have the passenger class here and the sex here. And if your focus was on the difference between the genders, then maybe this would be a preferable graph, because you could say within first class, we have this massive difference. Within second class, we have this massive difference. And in third class, less of a difference, but more people are dying anyway. If you want to compare the passenger classes, maybe this is a better choice. I wouldn't stop there whenever you're editing graphs. You need to go the next step to check you can see it well in a paper or a poster, and it might be different for the two options. One of the biggest frustrations I have is when people show me a graph, a comment, and the fonts are so small that I can't read what the graph is about. All I can see is the color. If when you cut and paste this into your document, you find that you can't read the fonts anymore, change the size first in SPSS before you cut and paste it across. It'll make a huge difference. Now, it's possible with the newer versions of Word and SPSS that you actually can edit these inside of Word, but depending on which versions you've got, that may not be possible. Now, that has still got too much information on it. I'm going to take the title off. I don't need passenger class written both times, so I could delete these. This I could possibly make smaller. Hold on, I'm going to take that one out as well. These I can make smaller by doing using numerals first, second, and third. Maybe that's too small. Might make that a little bit bigger again. I feel like that's probably a good size, and I personally might want to capitalize this. The only other thing here is which one we're focusing on and when we're writing up our results. Are we focusing on the death or are we focusing on the survival? Now, obviously, they both go together, but the easiest one to read is the one that comes from the 0 up. So if we were presenting our results in terms of survival, this is fine. And possibly I would make that colour a little bit paler. I don't like that at all. Maybe just a grey. I think perhaps it's that weird green colour that's a problem. Not quite sure why I keep saying that. So if the focus is on the survival, then that is easy to read. If the focus was on the death, then I think you would want to reverse these categories, and that might mean you need to reverse code. But then this should look, the font sizes should look good when we cut and paste them into our report. It's actually gone too big. Figure 1, and then we put a caption in. I'm not quite sure why it's put all the bullet points in there. We could take that out. And you can also, if you've got a long report, obviously insert the caption, this one, bar chart. I won't write it all out now. You need to describe what's in there. The good thing about using the embedded, this would be aligned better if that bullet point wasn't there, but the good thing about using these actual figure numbering system inside Word is that obviously you can generate a table of figures, but also it'll fix up the numbering for you as you go. So that's probably the best way to do it. There we go. Okay, so that's one type of figure we could use to show the results. Now this won't be enough. This illustrates what's going on, and this would be great for a presentation or a poster, but we kind of also need to show what the odds ratios are and the p-values. So for that, we will have to run the logistic regression. So if I run the logistic regression, binary logistic, survival is my outcome, passenger class, and sex, and that's the recoded one. Can't remember why I recoded it now. I probably did it for a reason, but if we don't like it, we could go back to the other one. Under the options, we want our 95% confidence intervals. I don't think I had anything else ticked, but just remember when you're doing logistic regression, if these are categorical variables and it doesn't show up with cat after it, you do have to tell SPSS that they are categorical here, and this is where we can change the reference level as well if we want to, but I'm just going to run it as the default model to start with. So this is where we want to check that we've got some consistency with how we're presenting our results. So if I have done a graph where I'm focused in on the survival here, ideally I would want the dependent variable to be coded for survival as well. And this means that we can interpret the results in a consistent way, talking about the odds of survival, rather than going back and forth between the odds of dying and the odds of surviving. So we kind of have to pick which one is our way of framing the results before we start. So I'm not going to change this. If I did want to flip this, I don't think you can just flip it in the analysis. I think you would have to recode this the other way around, because I think SPSS will always choose the last one as the one that it codes for 1. So you'd have to recode this as like survival 1 and died is 2 if you wanted the odds of dying. Now we have how the categorical variables have been encoded. We've got first class is 1, which is helpful. Second class is 2, and then third class is the reference level. So that's quite easy to interpret. And then we've got females as the reference level. Now this might be one that we want to flip, and I will show you why. So if we come down to our odds ratios, and we're looking here at the exponential beta column, so just Remember that you can edit this stuff even just inside SPSS. So if you need to, just change it. Now, we have passenger class, and I would probably, when I'm writing the results into a table, obviously I need to edit these because whoever's reading it won't know what these are. So they need to be edited. Before I get my final sort of table of results, I need to check that I've got the reference levels the way that I want them. And what we have here is the increased odds of survival for second class and first class as compared with third class. Now, because I'm looking at increased odds of survival, it would kind of make sense to then have men as the reference level and to show the increased odds of survival for women. And this puts all our odds ratios in the same direction, and I think that just makes it a little bit easier to interpret. So I would flip the coding of this one for ease of interpretation. So binary logistic, categorical, sex, the reference category, I want that to be the first one now. Did that not change it? I must have pressed something wrong. I didn't press change. Okay. It's enormous. That's a huge odds ratio. So in comparison to passenger class, huge advantage to survival in being female. So this is what I want for my results. And then I need to pick and choose the bits of information that I need from this. So this is where I can present this as a table, or I could present it as a graph. So if I go back to the PowerPoint, we could put it into a table like this, or we could put it onto a graph. Now, this is the graph that SPSS does not do by default, as far as I'm aware. In either case, it's worth just taking note of the information that we need, and we don't need all the information from that table. We really just want the odds ratio, the confidence interval, and then probably the p-value, even if the p-value is going to be converted to an asterisk. I think unless you have a really, really busy table, I think it's easier just to write the p-value on like they've done here. So I would be inclined to do that. So if we go to our output, it's often easier to edit these in Excel. And we can just decide we don't need all of this information. And then we can reformat this. So I've lost all my decimal places. So no. How many decimal places do we need? Okay, so we're going to have to write all of those as being less than 0.0001 probably. Whatever the standards are for the discipline. And then this is where we can also code for, not code, this is where we can rewrite our labels out to make sure we know who we're comparing. And we could change these rows around, obviously. So I don't know that it makes sense to go third, first, second. We can rearrange these if we want. We could put our p-values at the end, and we can reformat these with brackets if we want to. I think I'm going to remove this. We can write that differently. And this was the odds for females compared to males. Now, usually the constant should be included in the model, but we don't usually need to interpret this per se. So you'll often find that this is not part of the results. So this is, let me see, I think I've just about done. This is just about ready, and all I need to potentially do is put this into brackets. So if those are my main results, especially if I'm still just working in a draft. That might be where I put that into here. Now, if I was creating these results for someone else, I might give them all the options for how we could present them. We could do this, we could do this, and we could also do a chart. So the last thing I'm going to do, and well done to anyone who's got this far on this video, I'm just going to finish it off while I'm here, is take a look at how we go about doing this graph here. Now, whenever I can't work out how to do something in SPSS, my first option would be to Google it. So hopefully you do that too. There is a great post on how to do these. And the whole point of the post is about how you need to do them on a log scale. So because it's not, the odds ratios are not linear, we've got the lower end is all squished between 0 and 1, and the upper end can basically go up to infinity. I don't think you would ever get it going that far, but they're not symmetric, and that can lead to some misleading results. So this page, the point of it was to explain how it's misleading if you don't convert it to the log scale first when you're graphing it. But because these two should look the same, and if you don't convert it, it looks different. That's the point of the post. But anyway, he gives his code for how to get this graph out, which is incredibly helpful. So if you haven't had a go at using any scripts in SPSS, this might be a good one to start with. He gives a dummy data set and then how to create the graph using the log scale, but you can put your own data in here. So all you need to do is select all of this. In SPSS, open up a new syntax file, and that's just file new syntax. And then if you want to run this code, all you need to do is select all and then press the play button, and that will run it. So this is his automatic graph, but what you'll find is that in the process of creating that dummy data set, it generates a new little example data set for you that you can then use to edit. So you can edit these numbers right here, but you can also go into the example data set it has created, and you can put your own numbers in here. So if we have a look at what each of these are, this is all the information that SPSS gave us in the output. So the point estimate is our beta, standard error, exponential beta, lower confidence level, upper confidence level, and then we have an ID for each of these. So in our Excel file, you can see that I've actually already edited this. In this case, we do want to keep the beta and the standard error columns, which normally we would delete, but this is just for his graph. Then we have our odds ratios and our confidence intervals. I was just momentarily distracted by this number, but then I remembered this was before I had changed it from male to female. So if I take all of these and copy this in and paste it, now I've lost some of my levels here, so the ID might need to increase the width of that a bit. Reference. Now you don't have to do this, but if you want to have an explicit reference level in, then you can do that by just having all ones. And that will just give you a blank spot on the graph if you want to overlay something over the top. So this is now my active data set, and I could save this with a proper name. It's just called Untitled at the moment. So now when I run this graph, I only want to run this bit because I don't want to reload this data. I want it to use my data. And so here we can see third is a reference class. So if I wanted to add anything over the top of this graph, I could. I can edit how these lines look. But this is a really nice way to show the results. And here you can see the difficulty in having one of the results going in the opposite direction. Because I've got males here, it's actually really hard to see, I guess, to make that comparison between which is having the biggest effect. So it would make more sense to have this as being females, and then that would be up at like 12, and we would really see the difference between being female and male. And the last thing is it's actually reordered all of these things. I'm not quite sure why it does that, but something that you can do is put the order on here, and that will force it to order it the same way on the graph, and then you can take those out of the labels on the graph. There might be a smarter way to do it, but I haven't really played around with it that much. Now I can't remember which way around it's going to do it, so I don't know if that's if that's going up or down. 5, 4, 3, 2, 1. Okay, it's doing it in that order there. So if you want them to show up in the same order that you've got listed on that table, then number them from the bottom. I don't know, someone can dig around in SPSS to work out how it's doing it. Now, obviously I don't want that here, but I can edit these labels in the chart editor, which is probably a different video. And I also need to switch that up to being females, not males. So this was a very long video. I hope that was useful. I'm going to copy this graph, even though it's not perfect, as part of my results. And then I can have a think about which way around I want to present these results for this paper. If you've got a particular topic you'd like me to cover or a little demonstration of something that you need, please put it in the comments. I think I will be having some time to record a few more videos this week and next week. So if there's something that you need, please let me know.